Alright, lesson 2, relations, domain and range. I'll be your pilot for this evening through these notes. You've seen this all before, but let's do a really quick recap. I'll go as fast as I can so you're not watching this forever. Domain relates to all x values, range the y values. If we look at our little graph over here, the domain would be the farthest left x value to the farthest right, which is -1 to 2. We've used square brackets because they are solid dots, so they are included. Same with our y values. We're saying -3 to 3 is an element of y. That's what this little symbol is here. So that's the way to write domain. Really quick note, if you are writing a domain and you make a mistake, so if you did this, and you made a mistake, rather than drawing over the top of it, you need to cross it out and write 1, infinity curved bracket. It's very hard for an examiner or for myself to check that you've done the right thing there, and you would lose a mark in year 12. So it's a really simple thing. If you make a mistake with this stuff, cross it out, make sure it's clear that you're not using that domain or range, and rewrite it correctly. So let's have a look at a question here. So sketch and state the domain and range of this function here. And our function's just in there. It's kind of in set notation. It's a bit strange. And it's a bit small, this one, but there you go. And if we wanted to state the domain, we can write it just like it is in the question, actually. So we're actually given the domain here, so you can just really use that again. Or the range is actually going to be the same as well, being a circle. Of course, if we were sketching this, we would state all intercepts, but let's leave that for the moment. So make sure you're stating intercepts, always doing that. This question, we're looking at when 2x plus 3y equals 6, when x is greater than 0. Let's just find our x-intercept quickly. So 3 and 0. And y-intercept is going to be 3y equals 6. So let's quickly plot those points. We know that that is specifically what is happening here. Now the reason I'm not going to the left of the y-axis, that is when x is 0. And so I've done a solid dot here for 0, 2. If this was not including 0, then I'd have an open circle. And of course it's good to label our x-intercept. Always useful to label those things. That's really important to do those different parts. So we wouldn't sketch this section. That would be, wouldn't sketch this section. I don't know what's going on with this at the moment. That's really wrong. It's not part of the graph, so that's outside the domain, so that is all we need to sketch. You don't even really need that arrow at the right-hand side, just what we've got there. Okay, another one here, sketch x squared plus 2. So this is a quadratic that has moved up 2 units. The turning point, in fact, will be at 0, 2, so that's a good thing to check. Our endpoints, if we sub these values in for x, we can find out what these endpoints are. So -2 squared is 4, 4 plus 2 is 6, 1 squared is 1, 1 plus 2 is 3. Just to rewrite that. So if we've got -2 and 6, now that's an open circle because of our curved bracket. How do I do that so much? Curved bracket here means an open circle, and 1, 3 is a solid circle there. Oh, it's really wonky, but that'll do. And of course we would label all these values, so -2, 6, 0, 2, and 1, 3. So they're called endpoints. That's a really important way and a useful way of sketching these functions. They might not go on forever, and you need to take account of these different types of brackets. So square bracket including that value, solid circle, curved bracket not including that value, open circle. The domain for this is just like we had above, so -2 to 1. And the range is a solid square bracket from 2 to 6 with a curved bracket as it's an open circle up over here. We always read and write range from negative to positive, or bottom to top if you want to read the graph like that, and left to right. So it's kind of bottom to top values and left to right values. Sometimes you don't need to sketch things at all, so let's find the range of these two. I'm going to complete the square to get them into a form that we can use a bit more effectively. What's that going to be? Plus 4 plus 5 minus 4. Factorizing these first ones. And plus 1. So the range, or the y values, would be from 1 to positive infinity. This function's not been reflected or anything like that, so it would come down to 1 on the y-axis and then go up again forever. So it's 1 to infinity. Be careful with these questions. We need to first factorize out the negative. Oops. Should be a minus and a plus. Then we can start doing our matching values. This is the same as the last one. And just be careful when you're multiplying in this negative or any value you've taken out. You can't complete the square when you've got anything in front of your x squared term. So this is going to become negative bracket x minus 2 squared minus 1. So the range for this is it's been reflected. So this graph will be coming up to the value of negative 1. So we're going to go from negative infinity to the value of negative 1 and including it. And that's our range. The domain for both of these functions would be negative infinity to infinity, or r, you could write it as well. R. Sorry, it's been a long day. Implied maximal domain. State the implied domain. It's basically just saying state the domain. What would the domain for these functions be? What is the assumed domain? So for this case, we're going from negative 2 to 4, including them. So negative 2 to 4. Same over here, negative 3 to 3, and the range, I guess, in this case would be 1 to 4, inclusive, if you wanted to do that as well. All right, good questions coming up. These ones are a bit trickier. State the maximal domain and range. So we've got this rectangular hyperbole, and it looks like no, they're okay. Yep, I made a mistake over here, that's right. Minus there, minus there, minus there. It should be negatives. All right, back to 5a. So we've put our asymptotes in. How do we state this effectively? So the domain is all real numbers. It's going from negative infinity to infinity, but not including, 2. So it's going from negative infinity, but not including our asymptote, which is 2. Same for the range. It's all real numbers, not including positive 1 in this case, where our asymptote lies. You could write r in this case as negative infinity to infinity, that's fine. But yeah, just like what we've got there. Same thing here, domain is going to be, this one's a little different actually. We could write this as curved bracket negative 1 to oh no, that's not right, wrong one. The range is curved bracket negative 1 to infinity, because we're going from that asymptote of negative 1, but not including it, up forever. And the domain would be, same as we've been doing, r, not including 7 over 3, negative 7 over 3. One more. Be careful with these ones. We've got y equals the square root of 4 minus 2x. I think the best way to deal with these is always factorize out any common factors there, and so I can rewrite this as x minus 2. And the domain for this one would be curved bracket negative infinity to 2 with the square bracket, and the range would be square bracket 2 to positive infinity, and a curved bracket for infinity. I can't believe that's nearly a 10-minute lesson. Sorry that went for so long. Really important one though, so make sure you pick up on all the little nuances of sketching these different functions, particularly in regards to cancelling out any mistakes that you make like that, and how square brackets and curved brackets work, and super importantly, endpoints. Finding endpoints is really important. and can help you sketch a graph, as you can see in this example.